So this is the first lesson on our material in Unit 910. Topic in Unit 910 is constant rate of change. And the big topic that we're going to be looking at here, this covers the material in boxes A, B, and C, is we're looking at the concept of slope. What is slope and how do we calculate slope? Both from a graph and if we have the coordinates of 2 points. So the first thing it says up at the top of your page is it gives us the definition of what slope is. Slope, or rate of change, measures the steepness of a line. A steep line has a larger value for the slope. So the larger the number of the slope, the steeper the line is. The smaller the number for the slope, the less steep the line is. And the formula that we're going to use to calculate slope is this one right here. M equals rise over run. And M, as a letter, is just used to represent the slope. So instead of writing the word slope, we just put M. Now, what is rise and what is run? Well, you've got it on yours right there. It says rise is how much the line goes up. If the line goes down, then the rise is negative. Run is how far the line goes across. So let's take a look at an example here. We've got line AB here in this first graph. We want to find the rise, the run, and the slope of each line segment. So to find the slope, we're going to use this formula. Slope equals rise over run. Now the rise is the amount that this line goes up. So it starts down here at 2, and the line goes up to a y value of 7. So this distance in here, this is our rise. So what is our rise? Well, if it goes from 2 up to 7, the rise is going to be equal to 5. The run is how far it goes across. Well, it starts over here at an x value of 1, and it goes over here to 7. So our run is this distance across the bottom there. Let's just write this again. Our run is going to be, well, let's see, if it goes from 1 over to 7, that's 1, 2, 3, 4, 5, 6, 7. Our run is going to be equal to 6. So if our rise is 5 and our run is 6, what's our slope going to be? Well, we just put the rise over the run. So if our rise is 5 and our run is 6, there's our slope, 5 over 6. And if we wanted to, we could put that into our calculator and do 5 divided by 6 and express this thing as a decimal. So let's take a look at the next one here, line EF. Again, we want to do the slope, and this time I'll just say M equals rise over run. Now let's look at this line from E to F. It starts up here at 7, and by the time it gets to F, it's down here at 3. So what is our rise going to be here if it goes from 7 down to 3? Yeah. And because it's going down, it's got to be negative. So our rise is going to be negative 4. Across the bottom, we can look at what the run is going to be. We start over here at 2, and we go over to 7. So our run is going to be, let's see, 2, 3, 4, 5, 6, 7. Yeah, our run is going to be 5. So we've got a rise of negative 4 and a run of 5. What is our slope going to be here?
Negative 4 over 5.
So notice, here we have a slope that is a positive number, 5 over 6, and our line goes up as we go from left to right. So it rises to the right. Over here, our slope is a negative number, negative 4 over 5, and the line is going sort of down as we go from left to right, or it's rising as we go from right to left. So this rises as it goes to the left. Okay. So let's just put that information down here. Slope is positive Okay? So it rises to the right. If the slope is negative, our line rises to the left. Okay. So we've got two more examples down here. So if we look at this line CD, is the slope going to be positive or negative? And we can tell just by looking at whether it rises as it goes to the left or it rises as it goes to the right. This one rises as we go to the right, so the slope is going to be positive. If we look at the graph, we can work out what our rise and our run is going to be. What's our rise, looking at that graph there?
6.
Is that our rise? Is that how much it goes up by?
2.
Yeah, our rise is 2. Now, when Corey said that it was 6, what was he looking at? He was looking at, Jacob.
No, run.
And our run is 6. So our run is how far it goes across. So if we put these things together, what is our slope going to be? Well, it's going to be rise over run. Our rise is 2. Our run is 6. So if we put this fraction in lowest terms, we get a slope of 1/3. And again, our slope is positive. It's a positive number, just like we expect. All right, look at the last one here. G to H. Just looking at this, is our slope going to be positive or negative? How can you tell? What do you mean by it's in the negative section? Exactly. It's going down as we go from left to right, or it rises as we go to the left. So our slope is going to be negative. Let's see if we can get our rise and our run. We'll start with our run. I think that's a little bit easier. What's our run going to be here, Drake? How much does this go across by? 3, absolutely. 1, 2, 3. And what about our rise here? The rise is the trickier one. We'll give Corey another shot here.
No.
Close, close.
6.
It's 6. Now, because this line is going down from left to right, what does our rise have to be? It's got to be negative. Okay? So our rise is -6, our run is 3, so our slope is going to be -6 over 3. And if we do that division, -6 divided by 3 is -2. Okay, so our slope here is -2. Now looking at those 4 graphs, which line is the steepest line? Yes. GH is the steepest one. Now let's look at the values of slope. Okay, we've got 5 over 6, which is less than 1, 4 over 5, which is less than 1, 1/3, which is less than 1, and over here we have 2. Biggest number, steepest slope. Okay. So that's if we have a graph there. We can also find the slope of the line if we know the coordinates of 2 points that are on the line. If the first point we call x1, y1, so x1 is our x coordinate, y1 is our y coordinate, and the second one has 2 numbers in here, x2 and y2, we can use this equation here to find the slope. The slope is y2 minus y1 over x2 minus x1. So let's take a look at how this works here. We've got another graph with a line on it, and if we want to use this formula, I'm just going to write out the formula again here. y2 minus y1 over x2 minus x1. What we need the coordinates of 2 points that are on this line here. So let's see, let's pick a point right here, and we'll get the coordinates of this point. It's at x equals 0, y equals 4, so 0, 4. And another easy point is this one right here, which has x equals 6, y equals 0. So we'll call this point up here x1, y1, x2, y2. And let's just put these numbers into our formula. y2 is 0. We subtract y1, which is 4. Down on the bottom we have x2, which is 6. And we're going to subtract x1, which is 0. And if we do this subtraction, 0 minus 4 is negative 4. 6 minus 0 is 6. So we get the fraction negative 4 over 6. And if we put this in lowest terms, we get negative 2 over 3. So that's our slope, negative 2 over 3. Now, the slope that we got is negative here, and if we look at our graph is rising as it goes to the left or falling as we go from left to right. So, yeah, it makes sense that our slope here is negative.